Hello everyone, today we will be going over assemblies, but more specifically assemblies using the joint relationship instead of the constrain relationship. Joint has its strengths and weaknesses just as constraining does. The biggest advantage to joints is being able to quickly constrain things, whereas when you use constrain, usually you have to do it in several steps, and that will be demonstrated as we go through this video. To start off, to follow along with me, first you should have downloaded the vacuum fixture part packet that I will be sending out in an email, and we start by placing the mill base plate. So I just click on that and say open. There's right there. I'm going to right click and say place grounded at origin. So now we have a fixed part that won't move and it's centered at the origin where we want it. The next part we place will be the vacuum jig mount. So I say open. It comes in, and we could leave it at this orientation. I'll just leave it there for now, just so we can see it better. And then click joint. Now for joint over here, we have lots of options. We can click on any of these. If we leave it on automatic, it may or may not give us the correct joint that we want, but there's no harm in trying, so we're just going to try automatic. Click on this back point back here, and then click on this point right here. So what it does is it's going to place both of these points together, making the two surfaces parallel to each other as well, or not parallel, making the two surfaces mate to each other as well. So now it assumed rigid, so it assumed correctly, and that is the correct orientation that we want. And now all we say is OK, and using the constraint, that would have taken 3 extra steps plus getting it centered with constraint is tricky sometimes. So we were able to get it nice and centered and right in the right place in only one step, and it went a lot quicker that way. Now I will place the vacuum jig mount back and side, except let's use the no ring vacuum jig mount, and we will probably in the next video I'll show how to place that ring. So open that one and place. That's good. And we'll do the same with this one. Let's try to get this oriented correctly, and it'll make placing this one much easier. So first I want to let's just flip the X over, so right click and say rotate X 90 degrees. So now that's in the right place. So now, and what it's doing is it's rotating it about the axis that I'm saying. So now I want to rotate it about the Y axis. There it goes. And I'll just place it there. It's OK. Now this piece right here, it's not perfectly centered along the back, but it does line up with these holes that I actually drew using this. But for purposes of this video, we will do it without. We'll just use these holes right here. So I'm just going to click down here on this locating pinhole, and click there, click here. Okay, so it assumed rigid correctly, but it didn't quite get the alignment right. So I just click on the line here, and what this does is it's going to make you're going to click on two different surfaces, and it's going to make them parallel to each other or close to parallel with each other. So sure, we can click on that face first and then click on the second one, and I'm saying, okay, which face do you want it to be parallel to? And I say this one. Perfect. So now it's lined up how we want it. I just say apply. That way I stay in this dialog box and I can keep working with it. This next one, I'm going to keep on rigid, but it's important. So I want to mate this face right up against the edge right here, but mate it against this face. So I can click on, really I can use any three of these points because I can use corresponding points on the other piece. We'll just use this point down here. Now it's important to make sure we have this face active instead of like this axis or this face. I'll show you why. So if I was to click same point but I'm clicking on this axis, it's going to make that axis normal to this point right here. So I'm gonna work. Let's try that again. I just realized clicking on that axis is basically the same thing as clicking on that face. So if I would have clicked on like this face, that same point, okay, see it messes everything up. So that's not what we want. So the way I would have done it is clicking on this point, but make sure this face right here is highlighted. I do that, and it got it right there. Interestingly enough, it's going to take us an extra step instead if we clicked on the axis. So there's some playing around with this to learn how to use it most efficiently. Do that. Second point, what do I want it parallel to? I want parallel to this face here. I believe, except now it seems to be giving me a little bit of trouble. Whatever, just play around with it and get it to work. This one seems to be giving me troubles today, but we have it lined up how we want it now. Next part we will place is let's put in the 5 jig V2. Looks good there. Place it and say OK. And now if I come to joint, just get a preview of the different points we can do. Oh, quick side note, make sure you always click on the part that is going to move first, and then click on the part that's already fixed. So I think it's going to be easiest if we use one of these 3 points right here. Let's just use the bottom one. And we'll go along the side of it here. So I click on that bottom point, making sure I click on that side, and do the same thing over here. Fix our alignment. Looks good there. I'm clicking on actually the bottom face right here, and looks good. I'll say OK. So now that is in the right place. If I was wanting to be able to do a sliding motion with it, I would use I would have instead used the slider command, or you could probably do it with the planar one as well. And feel free to play around with that, but I think for now, with it rigid like this, that will be sufficient. Next part will be, it's going to be in this toggle clamp folder, and there's lots of pieces, and we are looking for 651 VTC, and it should give you a preview of the whole clamp right here. There we are. And I want to get to close to the correct orientation. I'll rotate the X. Actually want it flipped over from there, so I'll rotate Y twice. And that's close enough. Okay, so underneath there I'm going to check on my other drawing just to verify that. And okay, so we want the we need to insert some spacers real quick, and those are the 1/4 inch spacers. So I'll insert both of those, and I'm going to make this a 2-part drawing, so I'm going to pause it right here and start another one. And now we're continuing. So I want to use joint, and I can also just use constraint on these. It really doesn't matter. I'll just say rigid, click on that point, click on this point. Good. And I'll do the same thing with this. And we can actually, I think, just say flip. Yeah. So that just flips the direction too. So sometimes you want to do that. And I'll say apply. And now, in this case, this is where it would be better to use the constraint relationship instead of the joint, because with joint you have to specify a given angle, whereas then if I use constraint, I can constrain it using both of these two holes, as long as I lined them up correctly the first time. So I'm going to go to insert here, click on that bottom hole there. I want to insert it right there. Good. And then we'll do the same with that one. You can't really see it, some of these lines are hidden, but there we go. So that corrected our angle, and it's all set up the way I designed it to be. So I say OK, and now I grab the other spacer. So this one was 489, so now we'll place in 493. We're just going to use the insert. Okay, there we go. And now this is finished being constrained. And from here, we'll just go ahead and add in the bolts, and the next one we'll do bolted connections. We'll add in secure pins, or at least one pin probably along the back here that the 5 jig slides into, and we'll also go over placing O-rings, and that will be in the next video.